Okay, we're going to continue looking at how the Earth surface changes and how volcanoes, earthquakes, and landslides change the Earth's surface. Here's one example. This mountain is called Mount St. Helens, and this is what it looked like in the 1980s before it became active. And this is Mount St. Helens after it erupted. Okay, and you can see lots of differences. It used to have a peak where it came up like that, and now you can see the big crater that it formed. There's still some smoke coming out, and you can see where the magma that flowed up had already kind of hardened and made it where it looks like a little mountain inside a bigger mountain, or what was a bigger mountain. So volcanoes can change the surface of the Earth. Volcanic activity is one of the many ways that the Earth's surface changes over time. And again, here's another picture of a crater with the smoke coming out of an active volcano. Volcanoes change the Earth. They change the surface of the Earth by erupting matter from inside the Earth. And remember, this, once it comes out, is called lava. Okay? While it's still inside the Earth, when it's under the crust, okay, it's called magma. But once it erupts and comes to the surface, then it's lava. In most places, the Earth changes very slowly. Okay? These mountains form over long periods of time as two tectonic plates meet. Okay? And they begin to push on each other as they move. They crash into each other, and as they continue to crash and push into each other, they push and collide and push on each other until they continue to grow and grow and grow. But changes like this take long periods of time. But changes can also happen rapidly and even violently. Again, here's another picture of a volcano erupting, and you can have the volcanoes that erupt like in Hawaii where they're slow and the lava just gently kind of flows out, or you can have these that build up over time and create massive explosions of smoke and ash and poisonous gases. Okay, you can have change caused by lava flows. You can see where the lava was flowing over the surface. Okay, and you can see where this is what it looked like underneath, what the land that there was, and then this new landform that's formed over where the lava has flowed over it and hardened after it cooled off. Okay, changes can be caused by lava flows with steam, cinder, pumice, and ash. Those hot gases and hot ashes that come out of volcanoes can change the way it looks. You can see here's a picture of the forest and the mountain. Can change so that the landscape, it can knock out trees and cover them with bits of ash and poison the ground so that it's very hard for plants to grow back. Earthquakes can change the surface of the Earth. They cause the Earth's surface to shake, roll, and heave. And so here you can see an example where this used to be one solid piece and now it's cracked and risen up. Earthquakes under the ocean are what are responsible for tsunamis. That's that Japanese word for giant wave. Okay? And so when an earthquake happens underwater, where tectonic plates meet and crush underwater or slide past each other and jerk and create that movement, it can actually create a ripple in the water. And as the water ripples and gets to the shore, these giant waves can crash up on the shore. Landslides. Landslides make changes to the Earth too. They cause rock, soil, and debris to suddenly slide down a slope. Okay, so you can see here's our hill. It's got a slope to it. And the force of gravity has brought it down the slope. Okay, you can see where it either loosened quickly due to an earthquake, or if it rains too much and begins to loosen, the water and the gravity pull it down. Okay. Earth changes can look different. Earthquakes cause some landslides, but landslides can also be caused by water-soaked soil. Okay, if it rains too much and the soil, the land begins to slide due to being just flooded with water. And then here's a picture of a rock that's just one huge boulder of the rock has broken away from a hillside and come crashing down onto the road. Earth changes can look different. These pictures show the same road. What earth changes do you observe in each picture? Okay, here you can see a crack that went across the surface, and here you can see where lava flow has cooled off on top of it. Okay, so what would have caused this to crack? An earthquake. Okay, that same earthquake, that movement of the earth could have triggered the volcano to erupt, and then the lava flow out of the volcano and got to the road and cooled. So this one was caused by a volcano. But it both could have happened at the same time, with an earthquake actually causing the volcano to erupt. So there are 3 processes that change the Earth's surface rapidly: volcanoes, landslides, and earthquakes. And here are the sources for the photographs used in this presentation: the United States Geological Survey, the United States Forest Service, Georgia Boatman, Neptune.com, and these are the credits. These are the people who actually were credited with making this presentation for me to use. Okay, scholars, today we're going to be talking about what happens during landslides, what causes them, and things like that. Turn to this page in your science notebook. And we're going to be answering these questions after looking at a few pictures and talking about what happens, okay? So your title was Landslides. This you should have already written down from last week, and you're going to answer these questions this week. Okay, we want to know where landslides happen, what causes landslides, what changes occur on the surface, what changes occur on the surface, and what type of energy or forces are involved. And we're going to need a very important vocabulary word: erosion. And erosion is the movement of rock, soil, or other earth materials from one place to another by gravity, water, or wind. So I'm going to give you a minute to be sure you have erosion written down at the bottom of that page, and we're going to go through and answer some questions. Okay. Earthquakes can cause change. As we talked about before, earthquakes happen when tectonic plates shift on top of that magma layer. Okay, the crust on top of the magma shifts, and those tectonic plates bump and grind together, or they smush together, and they cause the earth to shake. Here you can see that the shaking has actually caused this building to fall over. Here are the cars that were parked there, and this building has fallen over on top of them. Okay. More ground shaking has led to this overpass, this bridge collapsing, and another piece of an overpass collapsing down. And you can see these are concrete roads. I mean, these are things cars drive over every day. You know, thousands of pound cars driving across it. They're made of concrete and then steel cables that run through that concrete. And the shaking has caused those to break and fall apart. Earthquakes can also cause the land to shift. Okay? And so here's a person standing right here. And then this building was solid and together. It was one building straight across. Okay? And you can see the land has actually shifted upwards. Or if it was up at this level, shifted downwards, depending on where it was. Okay? And that all occurred because of an earthquake. Land can also shift to the side. Okay? Here's a fence that was straight and connected, and you can see that it has actually moved over from where it was in a line with this piece of fence right here, and has actually moved over. Some more examples of the land moving over. You have where you can see the rows that a farmer has made with his plow. Okay, and you can actually see where they've shifted over and aren't straight anymore. Same thing here with the train tracks. You can see where that bump, where there was a tectonic shift and an earthquake occurred, okay, and actually moved the train tracks out of alignment. Here, the land shifting has actually caused a gas line to rupture and caused an explosion that actually leveled these houses. You can actually see here where the earthquake has caused land to break free and start to slide down the slope of this hill. Okay? The force of gravity, once the land shakes and becomes loose from where it was, the force of the gravity brings it down. Okay? So here you can see where there was a slope, a hill. Okay? An earthquake occurred and it caused enough of a land shift that the hill was brought down by gravity. Okay, you can actually see where there was a road that went around this hill, and it starts there, and then it has the landslide right there, and you can see where it continued on after that. And you can see down here houses and things just got shoved out of the way from this land moving down by gravity. Okay, here's another example of a landslide picture where the land has just come crashing down. Okay, and it could have been caused by either an earthquake, or this one may have been by rain. Too much rain can cause the soil to become loose, and that rain will wash it down with it, or again, it can just loosen it enough that gravity will bring it down, and you can see it crashing and damaging these homes, and just the dirt and water and mud running through the streets. Okay, here's another example where the soil and dirt has gotten loose, slid down the slope of a hill or a mountain, and is actually in a river, or colliding into a river, where you just see there's a rooftop there and just debris of this dirt and the land that once was there just flowing through this river. And here you can see where a house is being washed away with the river and the debris. So now you're going to go back to this page and answer, where did the landslides happen? What caused the landslides? What changes happened on the surface of the earth? What type of energy or forces were used? And this was all erosion, movement of rock, soil, or other earth materials from one place to another by gravity, water, or wind. One last part that we didn't get to cover in class yet is tsunamis. And tsunami is actually a Japanese word that means big wave. And you can see in this picture here, there's a beach area. Okay? You can see where the water usually is and how it's pulled back. And you can see even more sand and beach area than normal. And then finally, this is where the water comes back and crashes up. And we're going to look at more tsunami examples in class later.